Okay, so it's 11:35. I do not want to waste any precious time. Okay, teacher will start teaching. What do you have to have in front of you is just your brains. I just need your brains. I need you to have the paper that I gave you yesterday. If you have it on your phone, it's fine. And if you're using the laptop to teach, to listen, it's also good. Okay, I'm going to share my screen. Xavier, if it's possible to have the attendance for teacher. Okay, Tanisa, you also have to go to share screen and then allow teacher to share screen. If not, I can't share screen. Okay, some of you haven't seen your homework and teacher texted you and I still have not heard a reply from you. Okay, I want that person. You know who you are to text me now. Because I do see you online. I've got 22 students, 13 not here. Okay, am I able to share screen now, Tanisa? Yes, I am. Okay. All right, so this is teacher's slide. Teacher will send to you all, so you don't worry about it. I will send to you all. Actually, there's a game. My polymer teaching is actually a game on where already? Nearport. But because we don't have enough time. Okay? So teacher can't do it on Nearport. Okay. So that I know everybody is here, I want you to chat on the screen, chat in the chat. How has your holidays been so far? Or how do you feel this morning? Chat now. Why three people in one? Why all three of you all together? So during tuition time, you all are joining this class. But I thought it's a break time now. I was informed that the break time is 1:30 to 3:30. Sorry, 1:30, sorry, 11:30 to 1:30. Okay, so you all are parking there, is it? Okay, I want to see your faces. You don't have, yeah, we need proof of admission, correct? So either you turn on the camera or you have to take a picture and send to the class group. All three of you all are together. Xavier, take note now, they are together, okay? So don't put them as absent. Okay, I see Vision. Then I see Jerry. And then I see Vicky. All right. Okay, fine. All right. You can turn off your camera. Good. Okay. Let's start, yeah? Okay. Ready or not? Y'all ready? Uh Xavier, later when you send in your name list, please maybe then send another list of those who are not here. Okay? Thank you. When we get back to school, I probably will blunder all of y'all one time because all of y'all have been doing the homework. So either teacher get nasi lemak for the whole class or pizzas or something like that because you're working hard until next week for chapter 8. Okay, so those of you who have been doing your homework consistently, attending class consistently, okay, teacher will reward you for that. I always believe you reward those who do well. Okay. Okay. One more thing, when you do your homework, please don't do it together as with your friends. I want you to learn to do by yourself. If you study group and do together, I feel that it defeats the purpose. Okay, just teacher's opinion, but yeah. Okay, I'm gonna start teaching. Can you see my screen? If you see my screen, say yes or give me a thumbs up. Say something. Okay, good. All right. So polymer is actually quite fun. It's hard. It's hard, but I really like it. I really like it. Okay. So you know when I like something, I like you to like it as well. Okay. Okay. Thank you for responding. Okay. I will try to make it short. Okay. I tried not to make it 2 hours. So draggy. I try to make it as short as teacher can. Yeah, I'm just trying to get the chat out so that I can later see you. Okay. So. Okay, various products that can be manufactured by polymers. Okay, so what we're learning today is polymers. And teacher, where do you find polymers? Teacher, actually plastics. Your daily living rope, your um your pail, okay, your polystyrene, okay, all these are made out of polymers. How do you get polymers? Okay, it is when I have a lot of monomers combining together to give me a polymer. Okay, remember, many single monomers combining together and they will form a long chain molecule named polymers. And what they like to ask in exam is the definition. What is the definition of a polymer? Oh, okay. A polymer is a long chain molecule. First keyword, if I don't have a module for you today, but if you're writing down notes, this is what you should write down. Polymer is number one, a long chain molecule. First keyword, that is made up from a combination of many. The second keyword, the last keyword, repeating basic unit or repeating monomer. 3 keywords here for 1 mark. A bit unfair, but what to do? Okay. So polymer is a long chain molecule. Okay, first keyword, that is made up from a combination of many repeating. Second keyword, third keyword, basic unit or monomer. So let's see. Okay, today, where do we get polymer from? How do we produce? And the characteristics. I've got 2 types of polymer: natural polymer, synthetic polymer. Okay. What is natural polymer? I get it from our surroundings. Who can tell teacher what's an example of a natural polymer that we have in our daily life? Is plastic natural? Natural. Quite natural. Polystyrene not natural. Very good. Protein. Namrata is right. Okay. Paper is also cellulose. Yeah. So not too wrong. Okay. So sorry. Oops. Synthetic is I make it through laboratories and factories. So I'm going to show you actually. Starch. Okay. Starch is actually a natural polymer from glucose. So you eat starch, that's polymer. Your meat, so Namata said, protein, that's your polymer. Okay, what is Vicky, Jerry, and Vishen saying? No. Okay, and your nylon. Okay, you make robes and clothes with nylon, that's your natural polymer. Okay, you get it naturally. Okay, what's your synthetic polymer? And most of you answered that synthetically. Okay, let's see the difference. So your starch, and just now, Ashman mentioned papers of cellulose, your protein, okay, something that none of you mentioned yet, your natural rubber, okay, your isoprene, okay, it's coming from a natural, it's naturally found. Okay, what is man-made? Polystyrene, polypropylene, polyvinyl chloride. Okay, this is called PVC. So we learn a lot about PVC pipes, PVC clothes. It's actually coming from polyvinyl chloride. Okay, so it's actually polymer such an interesting topic. I really like it. Polymer is not good because it can give us pollution. Okay, so far you're okay, huh? So teacher got 3 types of polymer. 3 types. You must remember. Okay. Number 1, I've got thermoplastic. So I want all of you to imagine a plastic bag. Okay. A plastic bag, I can take it, I can remold it when I heat it up and I can recycle it. So all of you, the first example, I want you to remember thermoplastic. I can repeatedly remold it. I can take the plastic bag. I want to make a bow shape. I can. Okay, but upon heating lah, and I can recycle plastic. Okay, when I heat up a thermoplastic, this thermoplastic, they will melt and they will solidify when they are cool. So only a thermoplastic can be remolded, reshaped, and everything. Example of it is something that we see daily. Polyethylene, polyvinyl chloride, and nylon. Okay, so this is thermoplastic. Teacher wants you to imagine a plastic bag moving, a plastic bag changing shape. Okay, why teacher wants you to remember the characteristics? Because in exam they will tell you, okay, what is an example of a polymer that can be recycled and that can be remolded upon heating? You must remember it's thermoplastic. Okay, or they can ask you, polyethylene is what type of polymer? You must know it's thermoplastic. Number 2, so I want all of you to imagine something that cannot be moved. Okay, something that cannot, is not a plastic, something that is just staying in shape, it's very set. Polyethylene, but polyethylene is here, a thermoplastic. Okay, thermoset, imagine it is always very set. I cannot change it. Okay, it cannot be remolded after heating. If I do it like that, it's like that. I cannot change it anymore. Okay, and normally thermosetting, they will normally disintegrate or burn upon heating. And I cannot keep it for recycling. No, I cannot. Okay, examples will be melamine and bakelite. Okay, a kind of, melamine is a kind of glass also as well. Sort of that you can make from polymer as well. So you remember BM, Bahasa Melayu. Bakelite, melamine. Okay, they're just giving you all ways to memorize. Okay, bakelite and melamine. Okay, the third one, I've got elastomer. The name also very obvious that elastomer means elastic. I can stretch it and it will return to their original shape when released. Okay, and they have very high elasticity. Teacher, what is elastic? Elastic is, I don't know if you go to your grandmother's house right now and you take her old phone, the one that you it's sitting on a dial, and it's got long wires. Last time my brother used to do that to me. He will take it and stretch it, and he knows I'm standing there, and then he will let it go, and he will just hit me. He will take and stretch all the way to the other end of the house, and then he knows I'm standing there. He will let it go. He will come and hit me. Okay. Um. And not funny at all, but that's called elastic. It is able to be stretched and it able to go back to its original shape. I hope none of you brothers or sisters are like that. Huh? Okay, so example would be polyurethane, PU, we call it usually, or a kind of rubber, it's called SBR, styrene butadiene rubber. Xavier, teacher forgot to mention, yeah, Zenling, Zafran. Okay, they mentioned that they will be a little bit late, yeah. But Zenling already messaged teacher that day, and Zafran also just now. Yep, these two. So these two can put in bracket with reason. Okay. All right. Any questions so far? So I'm gonna go to my next slide. I'm gonna ask you, how many types of polymers do I have? Excellent. 3. Okay. Number 1. Thermoplastics example. Very good. Polythene, Polypropylene, PVC, nylon. Correct. Very good. Second one is called what? Thermoset. Very good. Examples of thermoset. BM. Very good. Bakelite, Bakelite, not Bakelite. Bakelite and melamine. Correct. Very good. Okay. What are the differences in characteristics of thermoset and thermoplastic? Very good. Okay. Thermoplastic can be recycled, can be remolded when heated. Very good. Thermoset cannot. Okay, it will burn. Thermoset, it burns upon heating. Okay, very good. My last but not least, you imagine my brother stretching and pulling back to me. What's it called? Correct. That's right. You got also elastomer. Perfect. Okay, elastomer. Elastomer. Okay. Examples of elastomer. SBR, styrene, butadiene rubber, and polyurethane. Correct. Very good. All of you giving me good answers. Very good. Okay, so well done. So it's um polymer. I'm breaking it down into a few parts, and as easy as I can, I'll break it up for you so you will remember. And then I'll do a few questions with you all. Then you will go like, oh my gosh, so easy. Okay. Okay. This part I need you to listen to me. Okay. I've got two types of polymerization. Two. Number one, addition. Addition. Okay, actually, if I teach you carbon compound first, you will find this part easier. But because I'm not going to be around the following 2 weeks from now, I have to do this first. Okay, so an addition polymerization is when I have my monomer having a double bond. And when I have my monomer having a double bond, the double bond will be broken, break. And then the polymer will come and add in another monomer will be added inside. So what happens is the monomers are all added together. When they're added together, they form a polymer. That's why it's called addition polymerization. So I'm going to show you an example. Okay, these are the examples, and don't worry, I will show you one perfect example so you don't get confused. Okay. So I want all of you, if you're taking notes, I want you to write down your notes there that for an addition polymerization, okay, all the monomers must have double bond. And you see together with teacher. Do I have a double bond for the first one? Yes. Do I have the double bond for the propene? Yes. Do I have the double bond for the chloroethane? Yes. And for the polystyrene, for the styrene also yes. And addition polymerization, your monomer must have a double bond. Must. And when you undergo polymerization, you notice all their polymers boliao, tak ada, hilang sudah the double bond. And I will teach you the step to get the hilang double bond shortly. Okay, let's look at the characteristics of each of it. Okay, polyethylene. It's durable and strong, and teacher use it, I told you, plastic bag, plastic bottles, and plastic packaging. So anytime you see anything plastic, that's a polyethylene. A polypropylene is usually your toys and your clothes, even sometimes ropes, okay, are made out of polypropylene. Your polyvinyl chloride, no need to mention, your water pipes, okay, your electrical insulators, they are strong and hard. Polystyrene, I use them as food packaging, okay, or heat insulators. Why? Because they are light and heat insulators. Okay. Okay, let me just see if I can teach you how. Okay, this is the exact step of how you get the answer. How do you get the polypropylene? Okay, or polyethylene or whatever. So I will actually start a whiteboard so I can actually show you clearly. Okay, so let's say teacher is taking, oh, sorry, someone asked me a question. Teachers, are monomers always molecules? Yes. Yes, you always. It's never going to be an atom or an ion. Okay? Um, if I don't answer you, please turn on your mic and ask, okay? Because sometimes I'm not looking at the chat. Okay, so teacher is doing ethene. So this is ethene. Again, you didn't study carbon compound, so you don't know what teacher is drawing, but it's okay. Ethene got 2 carbons. Okay, ethene plus ethene. Okay, this is what I call a addition reaction. Okay, a addition reaction, I'm adding the same monomer over and over again. Okay, teacher want to ask you class, number 1. Do I have the same monomer you see in front of you? Are they all the same monomers? Yes, okay. Teacher, what do you mean? Are they all double bonds in front of you? Yes. Okay. Number 2. Um, um, do they all have double bond between the carbon atoms? Yes. Okay. Now you watch what teacher is doing, okay? Now in a double, when I do addition polymerization, the first thing I'm going to do is I'm going to break their bond. I'm going to break their bond. I'm going to break their bond. This is beyond your level. This is actually above your level, but I'm going to show you the mechanism. So half a bond comes out, 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 half a bond comes out. And what happens is I don't have a double bond anymore. It becomes a single bond. I like chemistry because we rewrite everything. So in this carbon, I got H and H, I salin balik H and H. This carbon, I got H and H, I salin balik H and H. Remember, teacher broke the bond here, and I showed you this. I said the bond goes out. So I'm going to put one bond here, and I told you the bond goes out here as well. So I'm going to put a bond here. Okay, it becomes a single bond now. And I always tell them when I teach carbon compound is one carbon must always have 4 wives. One carbon must always have 4 wives. Let's count. Let's count the first one here first. Okay, this carbon has double bond. 1, 2, 3, 4. Okay, carbon on my left has 4 wives, correct. Then my 5A kids last year, teacher, why only the husband must have 4 wives? Why the wife cannot have 4 husbands? Okay, fine. This wife, 1, 2, 3, 4. Okay, they also got 4 husbands now. Fine. Okay, now look at the diagram at the bottom. Wait, I'm just looking at the name list. Can someone get Aaron for teacher? Um, is Christopher still at the camp? Okay, can I have sorry if teacher's troubling you. Can I have Vicky, if it's possible, get Aaron. Jinching Amelda. Teja Christopher. Adam Hafiz and Simi Yuga, please. It's such a difficult topic, this one, and I'm really breaking it down to make it easy for you. So I don't want anybody to miss. It feels so sad. When you hear it's much more better. Okay. Yes. Please go and get them for teacher and then reply back in the chat what they mentioned, or don't message. If you message, you will never reply you. Call. Okay? Right. So now I check this carbon. Do this carbon have 4 wives? 1. Thank you, Kuvan. Maybe that boy overslept or what? Uh, just try once in a while. And okay, thank you, Kuvan. Okay, 1, 2, 3, 4. It's not like Simi to miss a class. And then this carbon got 1, 2, 3, 4. So perfect. All my carbons now has 4 wives or 4 husbands. Okay, to see whether really Punchina what she's talking is correct or not, try the next one. Carbon, I got single bond now here. I got carbon again. Sorry, Yuga. Oh, Jerry, yes.
Oh shit, I meant to send two messages.
You are not muted.
Oh, sorry, sir.
And Rishan, $1. Okay, he will figure out why the $1. Okay, so carbon, carbon. All right, and then I've got, I like chemistry. I always say I like chemistry. Chris is also not answering the phone. Okay. Just if your friends are not answering the phone, just send them a text. One Sheena is finding for you in class. Please message her to tell why you're not present. Just send them a text. Let them get back to me. Let them be responsible for their own actions. It's not your responsibility. But thank you for helping. Okay, so I've got a hydrogen on top. Okay, there's a hydrogen at the bottom. There's a hydrogen on top. There's a hydrogen at the bottom. Now, teacher just broke the bond. So I need to put one bond here. I broke the bond here, so I put a one bond here. So can you see now each carbon has four bonds here? Okay, 1, 2, 3, 4, 1, 2, 3, 4. So what is an easy way? Teacher, what is an easy way to do polymerization reaction? So look at what teacher is doing. I'm going to do like this. C double bond like this. C, H, H. And I put an N in front. Because in polymerization is so many numbers of, so many monomers. So many. The N can be a million, can be 1,000. Okay. When I undergo oxidation, sorry, polymerization, when I undergo polymerization, this is what happens. I get a single, so carbon-carbon single bond. I copy back H, I copy back H, I copy back H, I copy back H. And remember, I told you just now, there's a bond here and there's a bond here. However, I put a bracket and I put a bracket because I do not want, it's going to form a polymer, right? I can't be writing 10,000, right? And I put an N here. And this, my dear children, is the only thing you need to remember for polymerization. Do you all understand what teacher just said? Yeah, okay. Tanisha says yes. Why N? Okay, good question. Because I don't know what's the number of N. So I'm going to close my screen here, my whiteboard. Okay, can I close it? Yep, okay. Okay. Oh, sorry. Okay. So Ashman asked me why N, teacher. So because I do not know how many monomers I'm adding. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and it goes on. It goes on and on and on and on and on and on and on. And I actually will get something like this where they all combine together. Remember, the definition of a polymer is a long chain molecule. This is my long chain molecule that is made up of that consists of many repeating basic unit or many repeating monomers. See, this is my repeating basic unit. 1, 2, 3, 4, 5, 6. Okay, so n is a very large integer. Yeah, so a very large number where I don't need to memorize them. If they ask me what's a polymerization reaction and you write this, very good. Your answer is already correct. Okay, so that's step 1. Okay, anybody has any questions here? So I want to ask you in addition reaction, okay? In an addition reaction, can I know um what is my monomer here? Let's say I'm doing ethene. What is my monomer in my addition reaction? Let's say teacher is doing addition reaction and I'm doing ethene. What is the name of my monomer? No point teacher teacher if you don't know how to answer. Maybe I rephrase it again for you. I want to get polyethene. What is my monomer? Very good. Very good. It's ethene. Okay, I want to get polypropene. What's my monomer? Not propane. It's a propene. It must have double bond. Okay, teacher want to get styrene. What is my monomer? Not propene, propene. Propene, not propane. Very good. It is styrene, correct? Okay. Teacher just want to mention one thing. In addition reaction, okay, do I have double bonds? Very good. And when I get a polymer, do I have double bonds? Very good. Okay. I'm asking this question so you understand what I'm saying, because after this I teach you condensation reaction, so you cannot get confused. Okay. Now, when I'm doing addition polymerization, okay, um, do I get only the polymer or do I get a polymer and a side product? Very good. I only get a polymer. Okay, I want to teach you something called functional group. Again, I didn't teach you carbon compound yet, so these words are new to you. So I want to say it out loud. Okay, if you look at my eyes, or if you look at teacher, do you think I'm Chinese, Indian, or Malay? No, it's not a trick question. It's a serious question. I want to teach you about functional group. And don't worry, I'm not going to eat anybody up. Oh my gosh, what difficult question is it? I don't know, bro. You don't know, bro. What? Indian. Okay. No, not religion. They're just not asking for religion. I'm just asking about the race. Indian? No lah, ayo. Okay, never mind. Um, you would think I'm Indian, right? Because of what? Okay, don't worry about the color of the skin. You want to talk about the color of the skin, talk about the color of the skin. I need you to say it out loud. My name. Okay, my name is Sheena. Hey, got Chinese people got name Sheena. Okay, my full name. Okay, fine. Okay, cannot talk about full name. Must look at my appearances. What about me makes you think I'm Indian? Ayo, this one not kebab question. Okay, I'll give you some hints. I can be the eye size, or you can be the color of my skin. My gosh, no answer. Okay, the skin color. Very good. Okay, finally. So picture is a bit. I'm tan, right? So I'm brown skin, dark skin color. So you would think I'm Indian, correct or not? Many years ago, my mom went to one part of the world, and she's about the same color as me, and someone asked if she's from China. Okay, because it seems one part of China, people look same color like teacher, people look like that. Okay, so don't be surprised sometimes. But anyways, all right? Anyways, why teacher ask you this? You know I'm Indian because big eyes or even the color skin. Okay, so that was my functional group. Functional group means, oh, you see teacher's big eyes, or see my brown color skin, I'm Indian. Same thing. Okay, functional group is something when you look at this, you know that that is an alkene group. Okay, so in an alkene group, okay, alkene group is something like Malay, Chinese, Indian. Okay, so an alkene group we call homologous series. Okay, and then a functional group. Okay, how can you say that teacher is Indian? Okay, functional group, that is called functional group because Ponchina has dark skin. So in an alkene, how do I know that this is an alkene group? Because teacher had a carbon-carbon double bond. I hope I'm making sense. Okay, you need to understand this concept. Teacher, how do you know this is an alkene group, teacher? Because I saw carbon-carbon double bond. See? When I see carbon-carbon double bond here, and that is the key thing to tell me that this is an alkene group. Just like, for example, if you see Who is Chinese in your class? Christopher. Is Christopher's eyes big or small? Small. Okay. So Christopher got small eyes. That is his functional group. Okay, so let's do that. Okay, Christopher got small eyes. That is called functional group. Okay. Oh, he's got small eyes. So what do we say? If someone got small eyes, what are they? Are they Indian? Are they Malays or are they Chinese? Very good. They are Chinese, and Chinese is, oops, and Chinese is what I call as homologous series. Who do I belong to? Okay, teacher put HS for now. No time to write. Okay, I hope that makes sense to you. Okay, that was addition polymerization. Now teacher going to do to condensation polymerization. Condensation polymerization happens when I take out something. Just now teacher add together. Now no, I will take out something. Normally I take out water, or normally I take out hydrogen chloride. Now I've been teaching you in chapter 7 of Form 4, HCl is hydrochloric acid. But if it's not in an aqueous form, it's called hydrogen chloride. Okay, so I've got two types, which is, okay, which is a tyrylene and a nylon. Okay, a tyrylene and a nylon. Okay, you see the word ester here, and you see the word amide here. Again, I will tell you what it is. Um, Now it's 12 plus. If when teacher is teaching, any one of you wants to eat, go ahead. I'm okay. You eat as long as you're listening to teacher. Go and grab some food, go and eat. Teacher's very okay with it. Okay. Now, still want to ask you a few questions and I want you all to answer me. Okay. Now, just now I taught you functional group, right? Just now I taught you monomer, right? Okay. Now I want you to look at my reactants here. I've got reactant number 1 and I got reactant number 2. Okay, you tell teacher, how many monomers do I have? How many monomers do I have? Not a trick question, it's answers right in front of you. Okay, Shavin says 3. Okay, anyone else? The answer is right in front of you. Even teacher has given out the answer to you. Okay, how many monomers do I have? Okay, all right. Good try anyway, Shavin. You're the first brave one there, so teacher appreciates that. And good job, every one of you. In addition polymerization just now, you only had one monomer. But in a condensation, teacher has 2 usually or more monomer. If you're taking down notes, take down notes. Addition only one. My carbon-carbon double bond. Doesn't matter whether it's ethene, propene, styrene, whatever. Only one type. I cannot be first ethene plus propene plus ethene plus propene plus ethene. No way, you crazy. With ethene, it's ethene plus ethene plus ethene plus ethene plus ethene plus ethene plus ethene. That's it. But in condensation, it doesn't work that way. Okay? Molecule number 1 and molecule number 2, for reactor number 1 and reactor number 2, they're different. So therefore, point number 1, I got 2 monomers. Okay, my second question. How many functional groups do I have? That means when I look at it, I know they are different. Like just now, you saw all carbon-carbon double bond only. Look properly and see how many functional group do I have? Very good. Okay, Anu is correct. two functional group because here the functional group is alcohol, OH. Here the functional group is COOH. For this example, yeah. So very good. In a condensation reaction, I got two or more. Or more means other examples, but this example here, teacher only got two different functional group. So the point to take note is, in this condensation reaction, I'm using two different monomers, I'm using two different functional groups. Okay? Teacher, how you know something is alcohol? How do you know something is carboxylic acid? OH is alcohol. COOH is carboxylic acid. So even if you don't know, teacher, I didn't study yet, no issues, nothing wrong. You can study now. Okay, what happens here is this, and teacher's gonna erase so you can understand better. See whether they have an example at the back. Okay, so what happened here is, teacher erase, you watch, what's happening? Okay. Okay, the hydrogen from one of the molecule from the alcohol reacts with the OH from the carboxylic acid, and I'm taking out a water molecule. So a water molecule comes out here. And what happens is this hydrogen reacts with another monomer that has OH, and this OH here reacts with another monomer which has a hydrogen. Because remember, it repeats and repeats and repeats. N amount of this reacts with N amount of this. It goes on and on and on and on and on. So I will get N amount of water. Okay. Now, remember teacher cut here, right? Okay, chemistry, I told you, is always very easy. We rewrite. Because teacher cut here, then I start with O. So you see, I start back with O. And because I broke the bond here, so remember, whenever we break a bond, we are going to, remember teacher taught you, it forms another bond like this. Okay, so this is the bond that it forms. Then teacher salin balik. C2H4. Teacher salin balik. C2H4. Then there's an O here. There's an O here. Now remember, I took out the water here. What is left? C and O. Teacher salin balik. C and O here. Then there's this whole benzene ring with C and O. The whole benzene ring with C and O. Okay. And then because I cut here, so I put my bond here and I close the bracket and I say N amount. So it's something like your addition polymerization. However, in the middle, I cut the water molecule out. How many of you stressed already seeing this? You can be honest. Don't worry. Okay. It is, I think if I see you face to face, it's easier to explain. So it doesn't matter. It doesn't matter if you didn't. Why does the O from the ethanol? What? What? The O from the ethanol? Oh, connects. That's the way it is lah. Because I take out. So let's call an ester bond. Whenever I take out this bond, sorry. Whenever I take out a bond like that, okay, right? The O will go and bond to the next thing that is next to it. So the only next thing that is next to it will be a C because the water came out ready. So teacher don't want you to stress because it's not so stressful also anyways. When I see you in person, I will show you more clearly. But my point to you is, point number one, I got two monomers. Point number two, I have two different functional group. Point number three, do I have a side product? Is there a side product here? . 。 . 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 。 . 。 . 。 。 . 。 。 . 。 。 . 。 . 。 。 . 。 。 . 。 . 。 . 。 . 。 .
.
Yes. Okay, there is a side product. In a condensation polymerization, must have a side product plus my polymer. Okay, must have a side product plus the polymer. That's it. No need to understand so much. You understand this already, teacher very happy. So this is called tyrolene. Okay. Again, you didn't study carbon compounds, so you may be a bit confused. But this is a COO group, and this COO group is called ester. Okay. When I teach you carbon compound, it will become more clearer to you. So don't worry. Now, I got another kind of condensation polymerization. So let's see whether you really understand what teacher said. Do you agree with my point number one? I must have two monomers. Do I have two monomers here? Look at the example in front of you. Do I have two different monomers? Monomer means two different molecules. Okay, Ashman says yes. How about the rest of you?
Yes, sir.
Yes, okay, very good. You got also, so good. Monomer number one, monomer number two. Very good. Okay, now let's go on to my second point. My second point, I said they must have two functional group. Like when you look at me, I'm dark skin. Okay, Indian. Okay, now what are two functional groups that I have here? Okay, let's see whether you all agree with teacher. In this first group, I've got an NH2. That's my first functional group. All of you agree with teacher? Okay. And then when I got another one here, COCl. That's my second functional group. Do you all agree with teacher? Okay. You all don't worry about the names or whatever. Later on, only the names. Okay. Now, first thing I told you that. Second thing I told you that. Okay. Third thing. Okay. For me to do the third thing, let me just erase some stuff first. Okay. What did I teach you about condensation? Condensation means I must take something out, right? Okay. What do you think I'm going to take out here? You see it in front of you. What do you think I'm going to take out? Very good. I'm going to take out HCl. Remember, in a condensation polymerization, I either take out H2O or HCl. That's it. That's it. I'm going to take out nothing else for your level. So correct, I take out HCl. That's it. Okay, and remember, I told you the side's also the same. I will take out one H, and here teacher will take out one Cl, and then it will bond all together. So just to bully you all a bit, I'm going to show you what happens here. Because I broke the bond here, so I'm going to do this. I'm breaking my bond here. I put the bracket. Why, teacher? Because I have the word N here, and I have the word N here. So N amount of that will give me what? Okay? And then in class, if you notice, I just salin balik. Chemistry is all about salining. Okay, look, itu salin balik, the whole thing. Okay, when I come here, I pause for a while. I write down N and H. I write down N and H. Okay, then just Ashman asked teacher just now, teacher, why connected like that? Because I took out the H and Cl. So I got nothing else to connect with. So my N will go and connect to my C. So N connected to my C because my C is connected to my O. C will connect to the O. And then teacher copy back everything here. Teacher copy back everything here. And because I broke my bond here, C and O, I put this curvy line. I close bracket and I put N. And I must add on N amount of HCl. Okay, now looking at it the second time. Looking at another example the second time. Was it difficult? Do you still feel confused looking at it the second time? No, not so bad lah. Okay, you roughly can get the idea. Okay, oh, this is what it wants. So point number 1, I've got 2 monomer. Point number 2, I got 2 functional group. Point number 3 is I must have a side product. Betul tak teacher got side product and polymer? Okay, if it's correct, perfect. That's your condensation polymerization. Anyone has any questions so far? Okay, before teacher move on, anyone got question? No, yeah? Okay. So this is actually the experiment. Teacher want to actually do the nylon with y'all. It's so nice. But it's so sad. I cannot find the chemicals. Okay. Hafiz. Is Hafiz in the class? Hafiz, can you, or even Fatin, Hafiz and Fatin. Normally, last time Amani and Akil Amani and what's the other girls? Mukni. Their parents are Prof. Khalija and Prof. Misni. They always help teacher to pass me chemicals if I need. Okay, can you ask your parents? You take a picture of this. Ask your parents, Fatin, and because Prof. Misni and Prof. Khalija taught me, so I can easily ask them. I'm close to them. But I don't know your parents very well. So can you just ask your parents, or if you want to give me your parents' number, I don't mind. Ask if they have in their lab 1,6-diamine and decane-diol dichloride. Okay. And if they are able and happy to pass to teacher, that means it's my first time ever in my whole teaching life in Sama that I ever get to do this experiment with the new syllabus anyway. So please do ask for teacher if they have it in their labs, or they can ask their friends. And guess what? We finally can do it. Because I asked the Form 6 schools, I asked so many schools, and no one can provide teacher. Thank you. Thank you for trying. Fatin and Hafiz, please take a picture of this so you can ask your parents, okay? Okay, thank you, Fatin and Hafiz for trying. Okay, so we will try and do this experiment if it's possible. Must we memorize the name of all the monomers? Yes. Yes. But don't worry, Jish. Because with the practice I'm going to give you, when I'm not around, teacher's going to print out the chapter 3 and chapter 4 questions. Even I'm going to do with you shortly. You won't believe it. It's really so easy. It's really so easy. Not difficult. Okay? By practice. Okay, what is the use of polymers in daily life? Okay, so some of the examples of polymers is very light, good insulators of heat. They're not reactive. They are resistant to high heat. Okay, and then for roof waterproofing, I can use the acrylic polymers. All your threads comes from nylon. The one that Hafiz, if his father has the nylon, will be so nice. We can actually do the experiment. Plastic bags when you all go out. And most of our medical and laboratory apparatus, sometimes they are made from polypropylene as well. Okay, so this is where we use it. Is it good? Is polymers good? Are polymers good? No, because they're plastics. So they are non-biodegradable. So they can actually cause a lot of marine pollution, and then the creatures will die and they will enter the food chain and everything. Okay. How can I make sure this doesn't happen? Okay, so we recycle. But this is more to common sense, biology. And then teacher will teach you the way for chemistry, how to answer. Okay, when you justify your answer, you must give a proper reasoning. Some of you just simply answer, you don't get marks. So when I do questions with you, then teacher teach you. Okay, now we have such things called degradable polymers, where I put additives into the plastics and they will to decompose naturally by bacteria. So can you imagine no more non-biodegradable? Now they're all degradable, okay, or biodegradable, okay? Or we can even say photodegradable. They are decomposed by light. See? So we actually can use polymers better. Okay, the biodegradable plastic cup. Okay, they will degrade by themselves by light. Okay, that's 4.1. Everybody okay so far? Okay, tell teacher, would you like to try a few questions to get a gist of what teacher's saying, or would you like me to continue 4.2, 4.3? You decide. Teacher's okay. No one dare to make the first move. Okay, we got a tie. Okay. Okay. So we still got a tie. We got 2 for continue, 2 for questions. Someone else has to decide. It's still a tie. Okay, 1, 2. Oh, I don't think it's a tie anymore. 3, 4, 5. Okay, sorry. No tie, no tie. I saw wrongly. I missed a few. Okay, so yeah, fair enough. I'll let you go drink water. Everybody go drink water. Go take 1 minute break and I'll come back to the questions. Okay? Eh, continue? No lah. Oh, continue from. Oh, oh, oh. Never mind. I already opened up, so let's not. We just do lah. We just do one question, maybe 1 or 2, huh? So these were all from trials of last year. Ah, my teacher tried contacting Amilda as well. I can't get her. Ira also tried to help me to give the number, cannot. So if anyone is in contact with Amelda, teacher would really like to hear from her. Okay, we do one question, just one. The definition of polymer. What did I say just now? Eh, are you looking at teacher's screen? Can you see my screen? Yes, okay, good. Uh, okay, what's polymer? Long chain molecule, first mark, but not even first mark, first point. Okay, so because we don't want to waste time, so let's look. It's a long chain molecule, 1 point, that is made up of a combination of many repeating basic unit. If you want to say repeating monomer, also correct. Okay, look at your diagram here. It is plastic bags. What kind of, the question says, name polymer as. What's your polymer? Thermoplastic. Oh, anybody got any other answer? Anyone got any other answers besides thermoplastic? No. Okay. I'll tell you what's the answer. It's actually polyethylene. They didn't say type of polymer. They said name the polymer. Okay, and plastic bags are usually made out of polyethylene. So that's why doing questions are so important. Okay, it's polyethylene, polyethylene, polyethylene. All these are accepted answers. Okay, next, oops. What is the main source of getting polymer as? I think I did not mention it just now. Where do I get synthetic polymers from? Where do I get synthetic polymer from? Yes, correct. Okay, they are from petroleum. All right. Okay. Oops. So we're getting a polyethylene. What is the type of laboratory? Wrong, Anurag. Okay. What is the type of polymerization reaction to produce polymer S? Addition. Okay. Additina, all new names I'm hearing today. Addition, polymerization. What's the structural formula for monomer S? Structural formula for monomer S. If I were you, I will circle the word monomer. Monomer must always have what teacher said. Very good. I must have double bond. Okay, so how to draw this? Because we are rushing for time. This is my ethene group. Very good. This is how I draw it. Okay, all right. All right, so that was one question. So I think that's enough for one question. I will now go to natural rubber. Okay, I hope your brains are all functioning really well. Okay. I'm enjoying teaching y'all. Okay, so when y'all have natural rubber, this is actually what you see in your natural rubber. Okay, you never knew it's so complex like this. You only see, oh, latex, that's it. Okay, but it's more than that. So latex is the white fluid from the net rubber tree when the tree bark is being tapped. So this is actually what you have in your natural rubber. Okay, it's called, your natural rubber is also called polyisoprene. Later, teacher will tell you how to get polyisoprene. Okay, and what is the structural formula of your natural rubber? It's isoprene because it's isoprene, so it's isoprene here, the monomer's name. Another name will be 2-methyl buta 1,3-diene. Okay, don't die it, 2-methyl buta 1,3-diene. Okay, that is your the name of your natural rubber. Okay, now look at the diagram that you see inside of you. So this is called your rubber particle. Don't get confused. The whole thing here is called a rubber particle. Whatever is inside, it's called your rubber polymer. In exam, students always get it upside down. Inside is rubber polymer. Outside is rubber particle. This whole thing is called a rubber particle. What's inside is your rubber polymer. That's what I want. Okay, so what happens here is I have a rubber particle. This rubber particle is surrounded by a protein membrane. Okay, the one that teacher circled just now is a protein membrane. And this protein membrane is negatively charged. Can you all see it, class? Or am I the only one seeing it? Can you all see this protein membrane in front of you? Yeah. Okay. I'm just trying to see why I can't minimize this lovely chat of mine. Keeps going so big. Oh well. I give up. All right. Okay. So, what I want is actually what's inside. I don't want what's outside. So there's a process, okay, that I need to do so that I can get the rubber polymer inside. What is that process? Okay, so let's see what's that process. Okay, yeah, so whatever I just said, this protein membrane of the rubber particles is negatively charged. Okay, and so these rubber particles will never coagulate. They will never become a liquid, a solid. They will always stay in a liquid form. Okay, so where can I find this natural polymer? I can find it in latex. So remember just now, teacher asked you where can I find natural polymers. Natural polymers are also in isoprene, okay, because they are natural. Okay. So is latex a colloid or latex a solution? Okay, because it does not dissolve completely in water, so it is a colloid. like your jelly. Your jelly is not a solution. Your jelly is actually a colloid. Okay? Because it's being dispersed separately in your water. Okay, so that's jelly, that's latex as well. Okay, is natural rubber a good? Actually, natural rubber is not good at all. Most of the natural stuff is not good except for a few things. Okay, so natural rubber is actually very soft, not good. Elastic, okay, okay lah. Okay, very low heat resistant. You take a rubber band. After a while, you leave it out, it becomes soft and sticky. Electrical insulator, they cannot conduct electricity, but they are good electrical insulators. Very easily oxidized because teacher got double bond there, right? So they will oxidize very easily. They can react very reactively with acid, alkaline, organic solvents, and they are waterproof. They are water impermeable because water cannot pass through. Okay, all these are natural rubbers and not so very good. Okay, so where do I use them? This is just very easy for you also, not to worry. Okay, I use them in tires, in boots, in gloves, in shoe soles. Okay, in rubber bands. However, okay, I want to ask you, is it good for the latex to stay in its liquid solution or is it good for it to change to solid? What do you think? They ask in exam, you know. Let's say you want to go from point A to point B. Do you think it's good for it to stay in its liquid form or do you think it should change to solid? Okay, Anu says change to solid. How about the rest of you? Liquid form. Okay, anyone else? Liquid form. Actually, liquid form is better. But do you know, if I don't put something in it, okay, the bacteria in the air will go to my latex and make it a solid. I repeat what I just said. Your latex, over time, the liquid latex, over time, if I leave it, the bacteria in the latex will go and react in it and make it to become a solid. So I have to take some action, okay, to stop it from coagulating. I have to do something. Teacher, what is coagulate? Teacher tak pernah dengar perkataan coagulate. Coagulate means it will all come together and become a solid. So this one came out in SPM this year. For SPM question, the polymer question essay, they asked you to describe this experiment. This was an exact SPM question. Okay, so how can I allow coagulation to happen? And how can I prevent coagulation? So my problem statement is if I add acid, does it coagulate? Or if I add alkaline, does it prevent it from coagulating? So my hypothesis is the presence of acid will cause coagulation. The presence of alkaline will prevent the coagulation. Okay? So they're just going to take acid. I cannot use strong acid. I cannot use strong alkaline. I must use weak for both because strong acid will destroy your latex. And I want to see what happens to the latex. I will fix the volume of latex. Okay, so I'm using latex and ethanoic acid, ammonia, my beaker, measuring cylinders, glass rod, and dropper. You will do this experiment with teacher in school. Okay, normally every year we will do together. It's very nice. Okay, teacher, take 3 beakers, A, B, C. I put latex in all of them, all same, 20, 20, 20. Then I put 2 centimeter cube of ethanoic acid in A. Then I put ammonia in B. And then C, I don't put anything at all. And then teacher see what happens. You look, when teacher put acid, it will coagulate. It's so beautiful. You will all be so happy. You put acid, straight away it's coagulating. It becomes a real nice rubber. But when I put ammonia, nothing coagulates. In beaker C, the one I told you we leave and do nothing at all, beaker C, it will just stay there. After 1 week, you will see it also coagulates. So maybe when we come back to school, we look at the new timetable. This experiment could be one of the first few experiments I do with your thermochemistry, and this one. Teacher will line up all the experiments for you. Okay, what's my point? Let's look. This one you must memorize. No matter what, you must memorize. Okay, came out in 2020. Oh, not yet. This one hasn't come out yet, the process. So all of you know I have my protein membrane. Is my protein membrane? No, I think 2021 it came out, sorry. Protein membrane, if you don't say negatively charged, you got no marks. If you say negatively charged, but you don't say the word protein membrane, you got no marks. It must be negatively charged protein membrane. Then you get the full mark. Okay? The negatively charged protein membrane cause the rubber particles to repel each another. Okay, so you have rubber particle number 1, rubber particle number 2, rubber particle number 3. In this diagram, got 3. In real life, got a lot. Okay, but teacher just showing whatever's here. Okay, and each of them of this particle, they are negatively charged. Okay, the protein membrane is negatively charged. Because they are negatively charged, so they will repel. All of you agree when it's negatively charged, you will repel or you will attract? Very good. It will repel. Teacher's asking questions so that it's not so boring for you all to just listen to teacher. Okay, so that's why teacher's asking questions. Okay, let me just work out on my. Sorry, just give me 1 minute. I cannot tahan this chat box so big, but I don't know what to do. Can y'all see what teacher is doing? Can y'all see me moving my chat box, or is it just me only? Do y'all see me doing this? Oh no. Up. Oh, come on, get alive. All right. Wait. Okay, see me, that's a teacher already. Okay, all right. Okay. So now I told you, right? I added acid, right? So the acid has hydrogen ions. And these hydrogen ions will now go in, if you can see all the green stuff, it will all go in between the negatively charged particles. So in your own common sense, you can understand hydrogen ions, which is positively charged from the acid, will neutralize. Keyword is the word neutralize. Keywords are 3 things. Hydrogen ions neutralizes the negatively charged protein membrane. Okay. So what happens is all these get cancelled out. You got no more negatively charged over here. All this negative charge goes out and no more. When all this negative charge goes out, okay, take out everything. That means no more here already. All neutralized already. What happens is this rubber particle will collide. Because I don't have any negative charges there. So this rubber particle 1, rubber particle 2, rubber particle 3, and of course many more, they will collide with each another. And when they collide with each another, the protein membrane will break. So point number 3 is rubber particles will collide with one another and the protein membrane will break. The protein membrane will break. Teacher, what's the point of you teaching me this, teacher? This. I want the rubber polymers. That's why I have to teach you all this. Okay, the rubber polymers will combine. Cannot say coagulate here. The rubber polymers from A, B, and C, or 1, 2, and 3 will combine and they will cause the latex to coagulate. And that's what I want certain times. And for certain times, I don't want that as well. Okay, so this is called the coagulation process of latex. 4 steps only. Okay, I'm going to close this and I'll tell you the 4 steps. Number 1, the protein membrane is negatively charged. That's why they are repelling one another. Remember in your mind. Okay, negatively charged protein membrane are repelling one another. Is as teacher is writing, you should write too. If not, what are you remembering? Number 2, what happens? The hydrogen ion from the acid, I hope you can understand my writing, will neutralize the negatively charged protein membrane. Teacher writing short form because don't want to waste time. Third point, the negatively charged protein membrane will collide with each other and break. When they collide with each other and they break, that's what I want, the rubber polymers. Remember, the inside one is called polymers. They will combine and the latex coagulate. 4 very simple steps. Okay? 4 very simple steps. Now, what if I didn't add anything? Nothing. Okay? I leave it in the air. Just leave it in the air. Same concept. If you learn bio, you will learn that there's bacteria, okay, in the latex. And it will give out lactic acid. And the lactic acid has hydrogen ions. Okay? When the lactic acid has hydrogen ions, the process is the same. The hydrogen ions will come in. The hydrogen ions will neutralize. The particle will collide and it will coagulate. Only that it will take a longer time if I leave it out. Okay, because my point is this, I've got bacteria. Okay, so I've got sheet rubber, block rubber, lump rubber, all sorts of rubber here. Okay, now how can I prevent the latex from coagulating? That means I want it to always stay in that liquid form. Teacher add ammonia. Okay, it's a weak alkali. Okay, what happens? Okay, so you already know that this is my rubber polymer inside. This is negatively charged. Now, I told you, no matter what, even if I leave it and I don't add anything, I still got bacteria. So lactic acid will produce hydrogen ions, and my hydrogen ions will be here, whether I like it or not. Okay, even if teacher didn't add anything, there's hydrogen ions. And then right now, teacher is adding the OH ions, which is my alkaline solution. I'm adding ammonia. Teacher, ammonia is NH3. How come you got OH here? Because ammonia solution is NH4OH. Okay, right? Yeah, Simi texted teacher also as well. Thank you. He just texted. So what happens is all my OH will go and neutralize my H. All my OH will go neutralize my H. All go and neutralize, 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 all neutralize. So no more hydrogens or bacteria, but look at this, look at my drawing. Do I still have my negatively charged protein membrane? Is it still negatively charged? Correct. It is negatively charged, therefore, oops, the protein membrane will remain negatively charged and they will repel straight away. Okay, so 3 steps teacher taught you here. Okay, here this is quite a fun stuff. Teacher will do, let you all create your own product from latex. So this is not necessary. Teacher will let you all do the experiment. Okay, now I want to tell you that natural rubber is not so good. Okay, so in order to make it better, I do vulcanization of rubber, and vulcanization of rubber came out for exam also as well. In the recent 2023 paper. Okay. Vulcanization of rubber is I'm producing a better, more elastic, better quality rubber between the polymer chains. Remember in Form 4, Chapter 8, teacher taught you alloys. And why are alloys better than metal? Because the alloys, the bigger size, causes the metal not to be sliding easily. So same thing. In a vulcanization rubber, a process, the double bond between the carbon, okay, will react and form sulfur cross links. This is what I want you to hear. Okay, and this sulfur cross links, just like your bigger atom or a different atom in your alloy, it is the one making the vulcanized rubber stronger. So teacher, how does it look like? The exact same question came out in exam, the exact thing. Okay. So here my double bond is here. Here my double bond is here. Okay. They're just adding sulfur. Actually, the right thing is sulfur, disulfur, dichloride. They're just adding disulfur, dichloride. I got double bonds here, double bonds here, and I'm breaking the bond. Okay, teacher, break the bond. So it becomes a single bond. So what happens? I'm going to form a bond here. I put one sulfur here, and it combines to the C. See? In example, teacher do like this. Okay. Same thing here. One sulfur here, one sulfur here. See? I do the same thing. And because I got another double bond here, I do the same. Sulfur cross-link, sulfur cross-link. This sulfur cross-link, oops, is actually really the one that causes your vulcanized rubber to be much better. So if you look at the sentence here, I'm putting disulfur dichloride in methylbenzene, okay, into your latex, and you will get a vulcanized rubber. If I don't want to use vulcanized rubber, what else can teacher do? Okay, I can use synthetic rubber. There's no double bond at all. Okay, and it's also free from sulfur. Okay, and it is more environmental friendly. I also can use peroxide. Teacher can also use iridation, and metal oxide. Very rarely this question comes out for exam. So this is an experiment. Okay, teacher take I will look at the procedure. Okay, they want to ask you, is a vulcanized rubber better or unvulcanized rubber? I take 2 rubber strips, okay, and I clip it in a bulldog. Okay, I measure the initial length. Let's say this is 50. This is also 50. Okay, measure them. And then I put a same amount, 50-gram weight here, 50-gram weight here. And then I stretch it. And then I take out the weights and I record back the length again. You tell me, class. Which one will go back to its original? Let's say I started with 50, unvulcanized also 50. Which one will go back again back to 50 after I remove the, let's say I pull it, the weight also I pull. Which one will go back to 50 once again? Vulcanized or unvulcanized? Okay, I have one person answering, teacher. Who else? Very good. It is vulcanized rubber, okay? That is one of the characteristics of a vulcanized rubber. It's elastic. Okay, elastic means, remember what I told you about my brother? He's able to pull the phone cord, okay? And then throw it back at me. Shoom, come back to me. Okay? So a vulcanized rubber is better. Okay, so let's see what's so good about the vulcanized rubber. Okay, the formation of the sulfur crosslink will reduce the double bond, not doable, double bond between the 2 carbon atoms, and it's very hard to oxidize. Okay, it will prevent the rubber polymers from sliding. Don't worry, teacher will give you this slide right after my class. Okay, and it can return. Remember, the key thing is it can return to its original shape when I release it. And a lot of energy is needed to overcome or break the bond, the sulfur link bond. So look at the unvulcanized rubber. Before stretching, it looks pretty good. During stretching, okay lah, very tense. After stretching, like orang lembik ni. Okay, it looks horrible. But my vulcanized rubber, before stretching, looks good. During stretching, okay, very tense. After stretching, it's back to its normal position. So vulcanized rubber is the way to go. Okay. Okay, let's look at vulcanized rubber and unvulcanized rubber. So very easy. Vulcanized rubber, good boy. Unvulcanized rubber, bad boy. All the good boys, all the good stuff goes to the vulcanized rubber. Number 1, more elastic. Number 2, very hard. Very high strength, high tensile strength, can stand a lot of weight. Resistant to heat and resistant to oxidation. Unvulcanized, everything is bad. So what's an unvulcanized rubber? It is your natural rubber. Okay, right. And I'm almost done. I don't know if you want to do a question or you would like me. Let me just show you what a bit more, what do I have to go. Okay, this is what I have to do, and then we done. Let me just show you. I'm showing you, and so it's really not a lot. So do you want me to continue and then we do question, or you want to do question now? Oops. Tell teacher? Sorry, I didn't see that. Okay, so all okay with one question and then we continue? Because after that, nothing already. The synthetic rubber never come out for exam. Never. Okay, so I will do one question. All right. Okay, so I need to go and search for rubber question. Yeah. I think normally they mix it with, let me just see if I can get just one on. Okay. All right, this is perfect. Okay. Can you see my screen?
Yes, sure.
Thank you. All right, so this is a per list question. So this is talking about the vulcanization of rubber, natural rubber. Okay, question number one. Ooh, this exact same thing came out for exam for SPM. Okay. So question number one, what is the meaning of rubber vulcanization? Never in exam they have ever asked this question before. Never. What is rubber vulcanization? Wait, no news from Christopher at all. It's very rare. I found it very, very weird. No one got him? Jerry and the gang? He's not around, is it? Is it still okay? All right. Okay. Okay. Um, so all those who came in late, just like Jagar and Anu last week, what was my punishment again for them? Was it dancing?
Teacher week also week.
Yeah, I remember Vic was okay. Vic, Anu, Jagar, yes. Okay. For today's lesson will be Simi, Christopher, Xavier, help me, Xavier. I cannot remember who joined in late, Xavier. Hafiz, was it Hafiz?
I think so, sir.
Okay, take note. Vicky or what, write down? No, Zafran with reason. Wait, they just want to take note. Anu, Jega, Vic, Sim, Hafiz. No, some more. Christopher, Aaron. Please add on for teacher. Am I missing anyone? Guys, come on. Tell me. Because Xavier deleted the
Teacher
messages.
Jerry and Rishan.
Jerry, no lah. Okay, if I miss out anyone, you all tell me. Okay, teacher can't remember because Xavier delete already. I can't do anything. Okay, let's do this question. So what's the meaning of vulcanization of rubber? Okay, the process of producing more elastic and quality rubbers through the production of crosslinks. Actually, I don't like the answer crosslink. What is the crosslink here? What's my crosslink? Hello. What's the crosslink? What crosslink am I forming here? Very good. I don't want just one person answering, teacher. The answer is right in front of you. What's crosslink am I forming here? Okay. Still one person answering, Ashman. I want to hear the rest of you. What crosslink is teacher forming here? Okay, correct. It is sulfur crosslink. Okay. So yes, it is a sulfur crosslink. Good job. Okay, next. The polymer of natural rubber is polyisoprene. What is the name of the monomer for polyisoprene? No brainer, no brainer at all. Very good. It is isoprene. Please, your spelling is horrible. Work on your spelling, please. Not peen, isoprene. Okay. And another name that teacher mentioned just now, the real name, 2-methyl-buta-1,3-diene. Okay, perfect. Explain the process of the vulcanization of rubber. Okay, I know that it's a long process and you may not answer the marking scheme correctly, but what do you think happened here? What did you do? What did you do and what was formed? Just give me keywords. Everyone, keywords. What did you do? What was formed? Okay, you're forming sulfur crosslinks. What did you add? If you want to form sulfur crosslinks, what must you add? Very good, you add sulfur. Very good. Okay, good job. Tanisa, if you don't mind, can you send back the post to teacher? Because that's the only way I can keep the record later. If not, it will go to you. All right. Okay. Very good. I'm adding sulfur. Let's see the answer, yeah. The double bond between the carbons found between the rubber molecules will react with sulfur. Enough, no need or other substance. Okay. Jerry, wait, Jerry, teacher's almost gonna finish. You hang on. Okay. Okay. And you are going to form sulfur crosslinks. Okay, you're forming a sulfur crosslink. Okay. What is the property of a vulcanized rubber? Very easy. All the good boy stuff. Okay. Give one example of vulcanized rubber. Where can I find vulcanized rubber? Where? Yep. Basically, almost anything that you find rubber or even natural rubber, it's also a vulcanized rubber. So shoe soles, tires, gloves, okay, pipe and hose, all these answers. So I'm not letting you all go until I finish a bit more, and whatever I'm gonna teach you now, not really coming out for exam. Very, very, very rare, but I have to teach it as well. So I'll try to finish it in 2 minutes because it's really, really not so important. Yeah. So 2 minutes, and then teacher will let you go at 1:10 before 1:15. Okay, and let's not forget to take a picture, yeah, after this. I want everybody in. So far, good or not? You all understand this chapter on polymer? Roughly, okay. I'm not saying 100% because nobody's perfect. But do you at least understand 80%? At least 80. Oh, sorry. Should have done it the other way just now. Okay, so ooh, synthetic rubber. Sorry. Sorry, class. Didn't mean to add on the minutes. Well, synthetic rubber. My computer doesn't like me today. No, come on, be good. doesn't want to be good. Okay. Okay, synthetic rubber is a synthetic polymer that is elastic in naturally or elastomer polymer. Okay, so synthetic rubber, I make it. Okay, so teacher's computer is not behaving. Most synthetic rubber is a byproduct of petroleum. That means it's man-made. Yeah. Okay. Example of synthetic rubber will be neoprene, SBR. Just now you learn under elastomer, SBR, and silicone rubber. Must know. Comes out in objectives, yeah. So what is good about synthetic rubber, man-made, yeah? Same, very similar to vulcanized rubber, very similar. Okay, except that I'm not adding sulfur here. Okay, it's resistant to heat, hard, elastic, heat insulator, resistant to oxidant, resistant to chemicals. So very similar to vulcanized rubber. Here, I don't have that sulfur effect. Why must we do this? Teacher, why must we have a synthetic rubber? Because I don't have enough natural rubber. I can't keep on tapping trees. Okay. Therefore, I have synthetic rubber. Okay. So these are places where I use it. Neoprene, your conveyor belts, when you go to the petrol station and you use the rubber hose, it's actually neoprene. So please remember next time you're using it, neoprene, 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 neoprene. Who is Nisha? Do I have a Nisha? Why is Nisha coming in now? Gloves. Okay. SBR, where the teacher use SBR, this is an elastomer, abrasion resistant. Abrasion means friction. Okay, they allow friction to happen. That's why it's your tires and your shoe soles. Okay, if it's natural rubber, vulcanized rubber, not so abrasion resistant and not so good. Okay, your silicone rubber, you use it for implants, medical implants. Okay, even your cooking utensils, your automotive components, your sealants, you want to glue things together. Okay, thiocol. Okay, you use it for gluing things together, or your oil, your solvent resistant. Okay, nitrile rubber gloves. Please don't ever take this for granted. They like to ask you this in objective. Sometimes you get so confused. So memorize one for each. Okay. Synthetic rubber, very, very difficult to decompose it. Very, very difficult. Okay. And so what do we usually do is we recycle it at our school. All the tires, we make it decorative substance. Okay. We reduce it and we reuse it once again. Okay. We can even discard tires to generate electricity. And that's it. We're done. Yay. Finish polymer. Done. Okay, I know some of you really have to go. So before 1:15, let's take a photo. If you don't mind turning on your cameras. If you do, I am beyond that, okay? Oi, Ashman is with, wait. Whose name is not appearing in my mind right now.
Ethan.
Yes, Ethan, that's right. Hi, Ethan. Hi, Teja. Okay, the rest of you, would you like to show me your lovely face? Come on. Hi, Jishnu. Hi, Yuga. Was that lesson helpful? Was it good? Yeah. Okay. I know it's such a rush, but I will. You understood better than thermo, fine. Okay. Thermo got a lot of calculations. Okay. What I'll do when I come back to school is I will print out for you the objective and this particular structure. So you just have to do the questions, okay? That will be your homework when I'm not around. Is that okay with you? Okay. Teja, are you using your phone or your laptop?
I am using my computer chair so I can take a photo.
Okay, can. Okay, Vicky, Jerry, Vishan, pick up everyone lah if possible. So the whole 1:45 hours, 1 hour 45 minutes, I showed you my lovely face. You better show me your lovely face now. All three of you. Sorry, not all three of you, all of you. Okay, Aaron, why you came in late, Aaron?
I always left.
I wish I can give you that answer too. Okay, all right, I'll see you again next week. Okay, Teja done ready now.
Hello, Nasha. Take now.
I think you got
Okay.
2 pages.
Yes, I got 2. Okay, 3, 2, 1, smile. Okay, next page. 3, 2, 1, smile. Okay, sure.
Okay, my kids are on their own, so I gotta go and see to them. I will see you next week. Next week we do chapter 5. Are y'all gonna die yet? Okay, that was Anu. Xavier said dying. Let me explain what I'm doing. Vicky and Jerry, if you all need to go, it's okay. Why teachers teaching fast? Short period of time. What I will do longer with you is I'll do questions. That's what you want, isn't it? So teaching teacher will do fast. Experiments and questions I do slow. Okay or not? Okay. Thank you, class.
Oh, thank you, teacher.
Bye-bye.